Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Veda Hamlin, and we're going to cover the unit circle today. And what I'm going to do is I'm going to construct all the angles and also all the coordinates. So we're going to start out with the angles. So the first thing I want to do is I want to go by every 45 degrees, which we know in a previous video is every pi over 4. So we'll do these things in radians. So, and I'll just say the words in angles. So pi over 4 we know is going to be our 45 degrees, which is right here. So that's pi over 4. And then this is going to be, 2 pi over 4. 2 goes into 4 twice, so 2 pi over 4 is going to be equal to pi over 2. And then we're going to have 3 pi over 4. And then 4 pi over 4, which is going to be equal to pi. And then you're going to have 5 pi over 4. Now 6 pi over 4. 6 and 4 are both divisible by 2, so this is going to be 3 pi over 2. And finally 7 pi over 4. And we know this is going to be 8 pi over 4, which is the same thing as 2 pi, but a lot of times you write this as 0. And sometimes your unit circle will have a 2 pi there as well. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And then 8 pi over 4, which is equal to 2 pi. Now what I want to do is I want to go by every 30 degrees, which is pi over 6. So this is going to be, 1 pi over 6. This is going to be 2 pi over 6, which is going to be pi over 3. I'll squish it in up here, so pi over 3. And then you're going to have, so 1 pi over 6, 2 pi over 6, 3 pi over 6 is the same thing as pi over 2, so I'd hit my 90 degrees as well. So 3 pi over 6, we're going to have 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6 is going to give us that quadrantal angle again. And then 7 pi over 6. And then 8 pi over 6. 8 and 6 are both divisible by 2, so this is going to be 4 pi over 3. 9 pi over 6, which is going to give us this angle again. And then we're going to have 10 pi over 6, which will simplify to 5 pi over 3. And then we're going to have 11 pi over 6. So we can go, 45, 90, plus 45 again, 135, 180, and then so on. So you can add 45 degrees or add your pi over 4s. And then you can also do your 30 degrees. So 30 degrees, 2 times 30 degrees is 60 degrees, 90 degrees, and then so on. Now our job is to go ahead and fill out these coordinates. What coordinate is at this 0? What's the coordinate at this 30 degrees or pi over 6? What coordinate's at pi over 4 and so on. Pi over 3. Pi over 2. Now I will build the first quadrant and then we'll just kind of use symmetry to build the rest of them. So first things first, this is a unit circle. So these quadrantal angles are really simple. So we know that this is a radius of 1, so this goes over 1 and then up 0. That's why that's the point 1 comma 0. And this is the point, x is 0, y is 1. And then over here, similar, I went negative 1, 0, and then this is going to be equal to 0, negative 1. Now these angles are a little more complicated, and I'm going to prove them using some triangles. So the first thing I want to do is let's go ahead and do this pi over 4. So if I have pi over 4, I'm going to kind of build just this triangle here. If this angle is pi over 4, we know that that this is the same thing as 45 degrees, and I know that this has a hypotenuse of 1. And the beauty of a 45-degree triangle is that this side and this side are equal to each other. So this is going to be, say, x, and this is going to be equal to x. So when I know this coordinate's going to go over x and up x. So that coordinate's going to be x comma x right there. So what I'm going to do is I'm going to do this using the Pythagorean Theorem. That these are the legs of this right triangle. So I have x squared plus x squared is equal to 1 squared. So this is going to be, 2x squared is equal to 1 squared. So, or just 1. So that means x squared is equal to a half. So it means x is going to be, since I'm talking about the first quadrant, this will be positive 1/2, a square root of a half. So this is going to be the square root of 1/2. Square root of 1 is 1, square root of 2 is 2. And we can rationalize this by multiplying top and bottom by root 2. So multiplied by this clever little 1, this is going to be root 2 over 2. So sometimes it'll write it this way, sometimes it'll write it this way if it wants to rationalize. So that means, this angle is root 2, this angle is root 2. So at the 45, this is going to be root 2 over 2, root 2 over 2. Now let's go to do this this pi over 6. Now it's fine. We'll get there. So if I have this pi over 6, which is 30 degrees, I know we're looking at something like this here. Now this is 30 degrees, which is pi over 6, right? That's equal to this angle right here. And that means this is equal to our 60 degrees. So what I'm going to do is I'm going to double this triangle, because I'm going to use something I know about another special triangle. Like in this triangle, I know that the sides are the same. Now in this case, what I know is that if I double this, this is going to be equal to 60 degrees. This is also going to be equal to 30 degrees, so that whole angle is going to be equal to 60 degrees. Now, if they're all equal to 60 degrees, we're talking about an equilateral triangle, so we're talking that all the sides are the same, and since this side right here represents that side, it's going to have a radius of 1. So this entire thing is going to have a radius of 1. This side is going to have a radius of 1. Now, if this entire thing is a radius of 1, this triangle up here is going to have a radius of a half. So now I can kind of ignore that dotted line. Let's just kind of pull out that triangle here. So this, is going to be equal to a half. This is going to be equal to 1, and this is going to be equal to x. So once I know x, I know that this is going to go over x up a half. So once I know x, I can find that particular coordinate. So again, Pythagorean theorem. These are the legs because the right triangle is right here. So I'm going to have x squared plus 1/2. All squared is going to be equal to 1 squared. So then x squared plus 1/4 is equal to 1. So x squared is equal to 3 over 4. So then x, since again this is in the first quadrant, it's going to be the square root of 3 over 4. Which is going to be equal to root 3 over 2, which is something that we're familiar with. So this angle here is root 3 over 2. So this is root 3 over 2, and this is equal to a half. Now this triangle here would be very, very similar because I'd build it the exact same way, except now your triangle looks like this. So this is just going to flip these coordinates. Now there's a quick little trick to kind of memorize these without having to build the triangles. Is everything essentially is root root something over 2, and we're just going to do we'll talk about the y coordinates first. So the first one, this one is root 0 over 2. If I plug in 0, well, root 0 over 2 is going to be equal to just 0, and then 0 divided by 2 is going to be equal to 0. So that's going to give us this next. This next one is going to be root 1 over 2. The square root of 1 is 1. So that's going to give us this. This is going to be root 2 over 2. This one is going to be root 3 over 2. And then finally this one's going to be root 4 over 2. So root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. So that's just kind of a quick way of memorizing that. And then whatever goes this way is just going to go backwards. You can see it's the exact same numbers in the reverse direction. All right. So now we can use some symmetries. What we know is if I go over here, all the y's stay the same, but all the x's are going to change signs. So for this point, this is going to be negative 1/2 root 3 over 2. It's kind of messy. Just that value changes. Over here, only the x value is going to change. So this is going to be minus root 2 over 2, root 2 over 2. This is going to be equal to minus root 3 over 2, 1/2. Now down here, they're both going to be negative, so just flipping this over is going to be, the x coordinate's still negative, the y coordinate's not negative. Here, the x coordinate is negative, and the y value is negative. So in this case, same points that are flipping over, except everything's negative. So minus 1/2 minus root 3 over 2. And then flipping back or flipping these things down, if I flip the first quadrant down, what's going to happen is the x values will all be the same, but their y coordinates will now be negative. And that's really the proof of how we build that unit circle. So if you like the content, please subscribe.